All right, this is our second week in trig, and so I want you to take a moment. You're going to pause this video and see what you remember from last week and special right triangles. When you come back on, we'll go through this warm up together. Okay, so the number 1 you can tell is the 30, 60, 90 triangle, and so remember the long side is going to equal the short side times root 3. X just equals S, and this equals 2S. So it says find X and Y. So we need to start with the only information we've been given, which is the 18. So if I solve for the short side in this, let me zoom in a little, it looks kind of small. I'm going to take the square root of 3 and divide both sides by it. So 18 over square root of 3 equals S. I need to rationalize that, so I'm going to multiply top and bottom by root 3, giving me 18 root 3 all over 3. And then you guys can see that these can simplify. So my final answer is 6 root 3, and we know that S is equal to X, so X is 6 root 3. So there's one of our answers. And Y is a little bit easier to solve for. Y is just 2 times S. So if S is 6 root 3, then Y is going to be 12 root 3. All right. So the following two were just finding the exact ratio of each trig ratio. This is really important because this is our basis for the unit circle, which we're going to spend a couple weeks in. So here was our rules for the 45, 45, 90. So tangent of 45 is opposite over adjacent. So tangent of 45 degrees is S over S, or just 1. And then if we go down to our 30, 60, 90 triangle, so here's 30. So short side is there, long side is short side times root 3, and hypotenuse is 2S. Sine is opposite over hypotenuse. So we have sine of 30 degrees is S over 2S, or 1/2. Right. So there's the warm-up for that. These are all really important concepts going forward. This first task, we're going to spend building up some of the information we need to be proficient with the unit circle. I know you may have memorized it last year. We won't be memorizing it this year. We'll just be using it to answer questions. So a little bit more involved than what you got in Algebra 2. So things that you might want to put in your notes is just how we look at standard position of angles. And it's important to notice this, because when I start putting a unit circle around this, we want to know that the x-axis here at the positive point, that's our 0 degrees. And we count up from that going counterclockwise. So initial side is always here at my x-axis in the positive point, and then terminal side is wherever else it ends up. And what we want to note is that if I'm going counterclockwise, those are always positive angles. And if I'm going clockwise, those are always negative angles. So here's what a positive 120 degrees looks like, and here's what a negative 120 degrees looks like. So no extra work here. This is just for your notes. You can pause the video and put these in your notes, take a picture, do whatever you need to do. All right. So we're going to use that initial side and the terminal side to figure out what are the measures of each angle. And so starting with A, you can see that this point is 3, 3 on this hypotenuse. What you want to do for this is draw a triangle. So you're going to draw your line down from your terminal side. Maybe put your little 90 degrees in there, and then realize if my point on this is 3, 3, that means my x coordinate is 3, or this side of my triangle is a distance of 3, and then this side, or my y distance of this triangle, is 3. Well, what kind of a triangle gives you equal sides? Well, we know that that is a 45, 45, 90. And so this angle here must be 45 degrees. There's no other choice. All right. Moving on to B, we can see whatever this angle is, because I'm traveling around in the clockwise way, it's going to be negative. Each sector of your XY axis is 90 degrees. So here's negative 90, negative 180, negative 270. So this is a negative 270 degrees. All right. C is also a negative angle. Notice I'm traveling around clockwise. And on this one, if I draw my triangle, I draw it like that. If this is my x coordinate, then that must mean that this side of my triangle is 2 root 3 in distance. And I'm going to put a negative 2 here, but we know it's really negative 2 in distance. So since my sides aren't equal, I know that this is a 30, 60, 90 triangle. And I can figure out which the short side is by saying, well, 2 is smaller than 2 root 3. So if we remember 30, 60, 90, get that up here. And of course, my lead is pooping out on me right in the middle of my lesson. Pull a pen out. That if I have 30 here, the short side is across from it. And here's my hypotenuse. So since this is the shorter side, the angle across from it must be 30 degrees. Because I'm going clockwise, it's going to be negative 30. All right. Again, this one, we are going to do a little bit differently. So when you draw your triangle length, you're always going to draw it like vertically down or vertically up to your nearest x-axis. And for this one, we know that this whole distance is 180 degrees. So we're going to find this angle first so that we can figure out that angle. And this arrow should be like that. So we know we're going to have a positive angle. So if I draw my triangle, and my x-axis is negative 1/2, and this is root 3 over 2 for my y value. This is my short side. So the angle across is from the angle across from the long side. So this angle here must be 60 degrees. So we know if this is 180, then we're going to take 180 degrees minus that 60 degrees to define my missing angle there. And that is 120 degrees. That's the angle right there. All right, so I'll put this whole slide up here so you guys can kind of see it. So you can finish taking notes on it, or pause, go back, take a look at the whole process again. So I'm going to give you a moment to pause your video. And when you come back, I will let you know what the answers are on this. If you need more explanation of these, I'm going to record a separate video where I walk through these. So go ahead and pause and see if you can get these right. All right, I'm assuming you've come back I can tell that this is going to be a 45, 45, 90 triangle. So this is 45 degrees here. I have 180 minus 45 is, I think, 135 degrees. It's going clockwise, so this is negative 135 degrees. This one, they told me it was 45 here, so I know that I'm having a positive angle here, so this one's going to be a positive 135 degrees. Now here, notice I don't have sides that are equal, so I know I am working with 30, 60, 90. It looks like my long side is here, so I'm going to say that's 60 degrees. And then I will have 180 plus 60, so 180 up to here and another 60 down to here. So, and this is traveling in a counterclockwise, so this is going to be a positive 240 degrees. Over here, I see I start here at my initial side, I go terminal in a clockwise direction, so it's going to be a negative angle. It's telling me that this is 1 and this is root 3. Root 3 is bigger than 1. You guys can check that on your calculator. So I know this is 60 degrees. So this little angle here must be 30 because this is 90 degrees. And so I will say it's negative 90, negative 180, negative 270, plus another 30. That's going to be a negative 300 degrees. Right. It's a little bit longer lesson than I'd normally like, but I feel like you should have had some of this. All right, we're going to finish off with coterminal angles. Coterminal angles are the same angle, just written different ways. So for instance, I can say that this initial side and this terminal side here is a positive 135 degrees, but it's also a negative 225 degrees. That describes the same terminal side, both of those. And so they give you this example here. These are all coterminal, and I'll show you why. I'm going to take you through this example. So I'm going to use this space down here. So here's our XY. And first they say, well, let's put in negative 330. So negative 90, if I'm going this way, negative 180, negative 270, and then 270 plus 60 is negative 330. So I'm going to come all the way over here. This is 60 degrees in here. This is negative 330 degrees. Now it says 30 degrees is coterminal with that. So if I come this way, if this is 60, this is 30. See, it's the same initial side and the same terminal side. Well, then how do we get 390 to be coterminal? Well, 390 is positive, so we go counterclockwise. So we have negative or positive 90, positive 180, positive 270, positive 360 plus 30, that's 390. So if I come around here, we can see that that is 390 degrees. And 750 is just going to be going around twice. So here's 360, I go around again, I come up, and there's 750. All right. You'll need to know this concept for the tasks associated with this. So now, if I go look at example 3, which of the following angles is not coterminal with the other 3? Well, they kind of gave us the answers above. We know 750, 30, and negative 330 are all coterminal. So it must be not negative 540. Part of your homework this weekend is going to be, hey, which of these angles is coterminal with 750 but between 0 and 360? How would I find that? Well, I would first subtract 360 from that, because each coterminal angle is just separated by 360 degrees. So 750 minus 360, that's 390. Well, that is still not between 360 degrees, 0 and 360. So then I would subtract 360 again, and when I did that, I would get 30 degrees. If it starts out greater than 360, you're going to subtract 360 from it to find a coterminal angle between 0 and 360. If it's negative, you're going to add 360 to it. So negative 330 plus 360 gives me that 30 degrees. So that's another way to check if an angle is coterminal. All right, I hope this made sense. I'm actually rethinking about not going over this with an extra video. So if you do need some extra information on this, let me know and I can send you one. I just don't want to take up all your time in the week. Right, have a great day, and there will be a task number 2 that starts getting us ready for unit circle.